And a good Wednesday morning to you. This weather video is driven by 802cars.com, representing 802 Toyota, Twin Cities Subaru, and 802 Honda. They're all located off of exit 7 on Interstate 89. Currently looking at a storm system centered just about right over northern New England. Was over Vermont just a little while ago. And you can see that in the upper levels, let's try to clear that out for you here. So first we're going to show you the upper level pattern here, which is a trough of lower pressure that's swinging through. It's cutting off or closing off into an upper level low. And then what we're going to do, that's at 500 hectopascals, about halfway of the atmosphere. Secondly to that, what we're going to do is introduce mean sea level pressure at surface. And you can see the surface low now is off to the east of us. And it's starting to wrap in some colder air and dry out the snow. This is all good. And we're going to get rid of mean sea level or surface pressure and go to 850 hectopascal. And you can see that it's centered just a little to the west there. So it's still a bit of a slant going out of the atmosphere. It's not completely vertically stacked. And so we still have a lot of weather, some lifting mechanisms involved and so forth, with the heaviest amounts of snow having already moved on through. Using the Storm Prediction Center's mesoscale analysis, this is at 300 millibars. You can see the jet stream is way off to the south, as you might expect. Zooming in to 500 hectopascals, about halfway in the atmosphere, you can see that here's the main upper level low with a secondary low beginning to take place. This typically happens off the coast of the northeast U.S., mainly off New England. And this is the start of what we call a Miller B nor'easter. Again, this is at 500 hectopascals, roughly about 18,000 feet or so. Then the next cut will show surface moisture, or excuse me, this is about 10,000 feet in the atmosphere at 700 hectopascal. You can see that it's solidly moist and where the position of the area of low pressure is. Now as we go down to 850, you'll see that continues to move a little bit further to the east, and so there's basically a slant in the atmosphere. I want to also show you that there's warm air that's feeding in, wrapping around this system, and there's this lobe of warm air advection, this sort of tongue of warm air advection. This is where our best lifting mechanism is, and it has now moved out of the state of Vermont, and it's more or less into parts of central and northern New Hampshire and into Maine. And these are temperatures that are above freezing at 850 millibars, or hectopascals. And our next look is going to be 925. Here at 925 is the next slice down. It's about 2,200 feet, I believe, mean sea level approximately. So a little lower down in the atmosphere, it's picking up some colder air that's beginning to wrap in around the area of low pressure and into the Champlain Valley, drying the snow out. Where's the wettest snow? This is going to be across parts of southern Vermont and into eastern Vermont. All of this is shifting to the east. Finally, last but not least, we'll go down to the surface here, and this is showing dew point temperatures and so forth. Well, except where it's cold, this is our surface low that's beginning to develop. Another way to look at that is the 2-hour pressure gradient, and you can see where the surface pressures are rising, where the gradient winds are fairly strong down here, and this is our surface low. And of course, kind of a slack pressure gradient where that upper low is out over here versus the surface low slanted through the atmosphere. This sets up the best mechanisms for heavier snow, and this is shifting out to the north and east. Okay, forecasting using model soundings, and this is a 3-kilometer NAM. Thank you, Levi Cohen, tropicaltidbits.com. So this is centered on a point in north central Vermont, 31 degrees. This is isothermal. So at surface, the temperature is roughly a little bit warmer aloft. Again, this is about 1 o'clock in the morning when this is basically setting up and moving through southern parts of Vermont. So let's take a look how it works here. So this is basically kind of during that lull. So our temperatures were isothermal, and we had a little bit of mixed precipitation type. That is, it was a little bit warm. So let's say this is our dew point temperature, the dew point depression closest to the ambient air temperature, 400, 300, 200, higher aloft here, 500 millibars, again about 18,000 feet or so. So we had isothermal up through about 850 millibars or so, which is about roughly the top of Mount Mansfield. And The isothermal nature is what produces the heavy snow, where temperatures are pretty equal, but a little bit cold aloft, where the dendritic snow growth is actually occurring higher than that, but basically causes this sort of Velcro-like snowfall to reach all the way down to the surface. So running this a little bit more here, this would be technically 10Z, which would be 5 o'clock in the morning when our snow is starting in north central Vermont. You can see the temperatures aloft begin to cool down, and this is what makes for drier snowfall. And now you can see that it's much more adiabatic, not quite super adiabatic. That would be this dotted line here. But the air aloft is colder, the atmosphere is more unstable, the type of dendritic snow growth, these temperatures here get away from this 0-degree line, all good. This is colder air aloft wrapping around the system as it departs, and so forth. What's the net effect? Drier snow. And in this particular case, the modeling is picking up on some upsloping, and this would be valid about 19Z. That'd be about 3 o'clock this afternoon, and it really does fall off and drop off this afternoon. So the worst is going to be over, and we're getting drier snow starting to work in, less of that heavy, wet snow that has been so problematic and has actually produced some power outages in some parts of eastern Vermont. Roger Hill, Wuthering Heights, thanks for watching.